Alright, so lesson 9 is our second lesson in factoring, and what we're going to be doing now is we're going to be factoring using the distributive property.
Objectives. Factor polynomials by using the distributive property.
Solve quadratic equations of the form ax squared plus bx equals O.
So factoring means basically we're expressing a polynomial as a product of monomials and or polynomials. Alright, I'm going to begin our first example with, I'm going to factor the polynomial, and I'm going to do the first rule of factoring is always look for GCF of your terms. So for A, I'm going to find the GCF of 12a squared and 16a. So I'm going to do my factor trees. Let me change that to red. I'll make that 3 times 4. So it's 3 times 2 times 2, and I have 2 a's. And then my 16 factors into 4 times 4, and I have, oops, that's a 2 and a 2 and a 2 and a 2, and I have 1a. Alright, my GCF is anything those two factor trees have in common. So I have a 2 here and a matching 2 here, so I have 1 2 is part of the GCF, and if I look, there's a 2 here and a matching 2 here. So I have another 2 as part of the GCF. There's no other numbers they share in common, but there's an A here and an A here, so they share an A. So the GCF is 4A. Alright, when I factor out my GCF, what I do is I write down my GCF, and then I make a big old parentheses. And inside the parentheses is going to be what I have left over for each factor tree. So I have a 3 left over and an A. So that's my leftovers there. And then I bring down my sign, which is the plus. And if I look, in this factor tree, I have 2 A's, which is 2 times 2, so I have a 4 left over. So there I am factored. Alright, now I'm ready to factor my other one, and I have 3 terms, so I'm going to have to find space. Let's see, 18cd squared and 12c squared d, and finally 9cd. Alright, my factor trees. I have 18 is 2 times 9, so that's 2, 3, 3, and I got a c and 2 d's. And my 12, it's 3 times 4, and my 3, 2 and 2, and I have 2 c's and 1 d. And then right here, I have 3 times 3, and a c and a d. Alright, for my GCF, since I have 3 terms, it has to be shared by all 3 factor trees. So my GCF here is going to be, let's see, I have a 2 in this factor tree right here, a 2 in this factor tree right here, but no 2 here. So there isn't a 2 that's part of the GCF. I have a 3 in this factor tree, a 3 in this factor tree, and a 3 in this factor tree. So they have a 3 they share in common, and there are no other numbers but that 1 3 they share in common. So now I'm going to look at my letters. All of them have at least 1 C. 1 C there, 1 C there, 1 C there. So C is part of my GCF. And let's see, and all 3 of them also have a D. A D here, a D here, a D here. So 3CD is my GCF. So on B, I write down my GCF, which is 3CD. And let me move that over there a little bit because I want you all to be able to see where I put my leftovers inside the parentheses. So in my first factor tree, I have a 2 times 3 times D. So that gives me a 6D. Then I bring down my sign. And in my second one, I have a 2 times 2 times C. 2 times 2 is 4, so I have a 4C left over. And finally, when I bring down my sign, always keep that same sign. And in my third factor tree, all I have left is a 3. So here's what it looks with the GCF factored out. Now, what you have to do is factor these other 2. So pause the video, try it on your own, and then check your work. Alright, here's what I got for my answer, and just in case you can't see it, in the second one here, I got 6xy times the quantity 2 plus 4y minus 6xy squared. That's what it looks like in factor form. If you have any questions, make sure you ask in class. Alright, now we're going to move into factor by grouping, and we're going to use the distributive property to factor polynomials that have 4 or more terms. And it's the only way to factor something with 4 or more terms. Alright, so polynomial can be factored by grouping if all of the following situations exist. It has 4 or more terms. Terms with common factors can be grouped together. And the two common factors are identical or additive inverses of each other. Here's basically what happens. If you look here, these two terms are grouped together and those two are grouped together. These two share an x in common, that's their GCF, and here's what I have left over when I take out that GCF. These two have a y in common, that's their GCF. When I take it out, here's what's left over. When you take that out, and then if you'll look, they have the exact same thing in the parentheses. So actually, out of these two terms here, the first term and the second term, the GCF is the quantity a plus b. So when I factor that out as a GCF and write that down, I'm left with my leftovers, x plus y. Okay, so here, we're going to group these together, and if I look here, 4 and 8, they got a common factor, and they both have b's, and this one 3 and 6. So these have common factors, these have a common factor. If you need to, do your factor trees and write everything down. If you can't see it. So, and let's see. They have a 2 and a 2. So we have 1, 2, a 2, and a 2, another 2, and they both have a b. So 4b is the GCF of the first term, so 4b. And then what's left over is an a plus 2. And then I'm going to find the GCF of these two terms. I have a 3 and an a is all I have, and then I have a 2 and a 3. So the only thing those share in common is this 3. And it is a positive 3. And then what I have left over in the first one is an a. I bring down my sign plus, and I have a 2. Alright, then if you'll notice these groupings here, this one has the quantity a plus 2. This one has the quantity a plus 2. So both of these terms share the a plus 2. So that's one factor. And then when I take that out, I'm left with the other factor, which is 4b plus 3. And if you FOIL this out, you'll get right back what we started with. Alright, additive inverses. It's a number and its opposite. So the sum of a number and its additive inverse is 0. And here are some examples of some additive inverses. And if you add them together, even the one with the variable here, you're going to get 0 because y minus 3 plus 3 minus y. Combine my 3's together. 3 minus 3 is 0. Y minus y is 0. So if I add them, I get 0. So they're additive inverses. Alright, so here we go on this example. So first of all, we're going to group common terms together. And if you'll notice, those are both multiples of 5 and they have an x. These are both multiples of 3. The GCF in the first one is 5x. Once I take that out or divide that out, I'm left with 7 here and a y there. And if I factor out a 3 out of both of those, I divide out a 3 out of each term, I'm left with a y minus 7. Alright, these terms are additive inverses of each other. Here's what I can do. I can divide out a negative 1 out of here. That's what's the easiest way to do. So 5x, 7 minus y. If I divide out a negative 1 here, what that's going to do is it's going to make my 3 negative, and it's going to change my y to negative, my 7 to positive. So what it really looks like is alright, now I have these two terms that are the same, 7 minus y, 7 minus y, so 7 minus y is that factor, and I'm left with 5x minus 3. That's my other factor. Alright, so try this one on your own and see if you can figure it out. And once you figured it, I think you figured it out, restart the video and check your answer with mine. Alright, here's what I got. If you're ever unsure of what you got, all you had to do is do the reverse operation, multiply, and see if you get what you started with to check your answer. Alright, here's something called the zero product property. What the zero product property is it says if two numbers multiplied together equal 0, then one of them has to be 0. And we're going to use this property to solve this equation. X plus 4, the quantity x plus 4 times the quantity x minus 4 equals 0. So here's our problem we're going to solve. It's similar to that problem a minute ago, which we didn't solve. Zero product property says if two quantities multiplied together equal 0, then either the first one has to equal 0 or the second one has to equal 0. And then once you have these set to 0, all you do is solve both of these smaller equations. Two-step equation, 3d equals -4 divided by 3. So my two answers, the solution set is either 5 and -4/3. There's two solutions because we have two variables up there, two d's. So one solution is 5 and one solution is -4/3. Alright, here's another one we have to solve. And the way it looks, you wouldn't think you could use the zero product property, but we can because all we had to do is subtract 7x from each side, and our equation is 7x. X squared minus 7x equals 0. Now we can use that zero product property. But first we have to factor to be able to do that. So factor trees, I have two x's here and a 7x here. So they share an x in common. So the x is the GCF. And what is left over in each factor tree is x minus 7 equals 0. Now I can use that zero product property that says if I multiply two quantities together and one of them and it equals 0, then either the first one has to equal 0 or the second one has to equal 0. First one's already solved for you, and all I have to do is one-step equation. And my solution set is 0, 7. Alright, here's one for you to try. You try this one. You're doing the same thing. Get it equal to 0, factor it, then set each factor equal to 0 to get your solution. So pause the video now and give it a whirl. So my solutions to this problem were 0 and 9. Were yours? You can always plug your solutions in to the original equation and see if they work to check. Alright, here's the dreaded reading problem. So here it is. Nolan Ryan, the greatest strikeout pitcher in the history of baseball, had a fastball clocked at 98 miles per hour or about 151 feet per second. If he threw a ball directly upward with the same velocity, the height h of the ball in feet could be modeled by the equation h equals 151t minus 16t squared, where t is the time in seconds. Now the question is, how long will the ball remain in the air before returning to his glove? Alright, so we're going to use our equation, and we want to know the value of t when the height equals 0. That's when it hits his glove. So what we're going to do is we're going to substitute in 0 for h, 151t minus 16t squared, and we're going to find the GCF, and we're going to factor. Okay, I couldn't really find a common factor with 151 and 16, but I do know from looking at this that they share a t in common. So if I factor out that t, that gives me 151 minus 16t. And now I have two factors that I can set equal to 0 using that zero product property. T equals 0 and 151 minus 16t equals 0. We obviously, time equals 0, the ball's going to be in the air longer than that. But let's see, if I add 16t to each side, I get 151 equals 16t, and then I divide by 16. 151 divided by 16 is T equals 9.4375 seconds. So the ball will remain in the air 9.4375 seconds before returning to his glove. And that's all, folks.